Good morning. Welcome to part 9 of Getting Started with FDOT Connect for OpenRoads Designer. Today we have a presentation on drainage with SUDA and geotechnical with the gINT tools. Your presenter for the day is Vern Danforth. And of course, as always, we do have a question and answer dialogue available to you as part of the GoToWebinar dialogue. So find that question and answer dialogue. If you have any questions along the way during this webinar, feel free to enter those questions in the question and answer dialogue. We will be answering those questions as we go. Also, we'll take some time towards the end of the webinar if there's some time to answer the questions additionally that may not have gotten answered along the way. If we don't manage to answer your question during the course of the webinar, we will be compiling the questions into a document, a question and answer document that will be posted on our website along with a recording of this webinar. That should be posted within about a week in the posted webinars section of our website. So without any further ado, I'll go ahead and turn things over to Vern, and he will give you your presentation today.
All right, thank you, Matt. As it says here, this is a Getting Started with FDOT Connect for OpenRoads Designer session, part 9, and hopefully today we can cover the Getting Started directions and tools for both the drainage and the geotechnical tools within the new workspace. All right, so let's go forward to the first slide here. So if you don't already know, the Bentley software is changing for drainage design, the modeling and the plant production. It is now a product that's actually been in the Bentley software since SS3, SUDA or SU, Subsurface Utility Engineering, and Subsurface Utility Design and Analysis. We will talk a little bit about next-gen plans as it relates to the drainage presentation in our plans. We'll be talking also about summary of drainage structure sheets, drainage tabulation. As you can see, profiles of drainage structures. We'll talk about cross sections as well. And then a little bit about the legacy geopack drainage integration and ASAD integration, time permitting. I'm also going to, at the end of the drainage, we'll slide over into the geotech or the soil borings and show you some of the tools for that as well. First thing I want to point out is the best way to get familiar with the SU or SUDA tools is to actually go out to your Bentley Learn server and do a search for SUDA or SU, and it will bring you up a learning path of things to get started with. That's how most of us here in the office have learned the software. And it's a great resource right now for learning all of the tools that are at your disposal. You can also go out to your Learn server. There's several, as you can see, quick starts. There's a few special interest group sessions that have been done. There's also on the Bentley Connect Advisor, there are some YouTube videos. So there's lots of resources that Bentley has provided for getting to know the new SUDA tools. So essentially, in FDOT Connect, we're going to be focused on the tools in these 5 areas, essentially laying out the 2D network, both your nodes and links, as well as any utilities in 2D. The nice thing about SUDA is you're laying things out in 2D, you actually get the 3D that goes with it. And then I didn't actually have a numbered or a bullet here for the design, but it will go through an analysis of your layout, and I'll show you some of this live here. And then we'll talk about plan development for obviously plans, profiles, section details, whatnot. Automated pay items, summary of drainage structures, and where you'll get the information for that. And then drainage tabulation reports or what's going to be called flex tables. You'll learn more about that as you get to know SUDA. So obviously in plan view, we typically have call outs of where the drainage structures are. This is a typical sheet that you would see on a set of plans, roadway plans. It is presented in both the plan and also in the profile. And in SUDA, it'll be very similar. You'll get a 2D representation of what you're laying out. And then profiles, right now, SUDA doesn't have the ability to project onto a roadway profile, and we likely won't be moving towards that. We're going to rely more heavily on a 3D representation that goes along with the model. So you'll actually see where the two interface together in more of a 3D model, and that's kind of how we're talking about delivering it. Now you will be able to do trunk line profiles from structure to structure that can be presented in the plans if you need to show more of that detail. Obviously, a lot of these labels and things are all going to be automated or are automated in SUDA, and I'll show you some of that as well. If you don't know, I'll get into it here, but there is actually a separate workflow section for the SUDA or SU utilities and the menu changes, but I'll get into that as well. This is an example of the 2D layout, so you can see lots of things are referenced in here. There's a pond, but essentially here are the links, the nodes, and I'll show you more of this in detail as well. A little bit closer view, you can see some of the labels that are placed on there. As far as getting the information in, there is an extract from graphics, but this is more so for existing utilities. You could possibly export your geopack drainage in the old SS4 to a SUDA model and then import from SUDA to the OpenRoads designer. So that is a capability. But for the most part, there is a tool there, extract from graphics, that's mostly for existing utilities, and I'll show you some of that as well. Like I said, as you lay things out in the 2D, you get the 3D along with it. You don't have to do anything, it comes along free. So you can see that as I zoom in here a little closer, the detail of all of the 3D structures. And this is what we're going to rely on heavily for delivery to give the contractors a much better representation of where we anticipate all of our drainage needs, drainage design intent, and these are all intelligent in the model. So if they need to know what type it is, that type of thing, it's all going to be accessible through the information dialog. Flex tables. So flex tables are kind of like database reports. Not kind of, they are. SUDA actually tracks everything in a separate database within the design file. And so when you first open up a design file, it's going to create a blank database, a SUDA database, and then everything that you place into the file gets actually placed into a utilities database. Just like any database, you can generate custom reports from it, and that is the power of StormCAD or SUDA in this case. So examples are similar like this. You can do a conduit table that shows all your pipes. These are totally customizable. As a matter of fact, I'll show you some that have been customized for FDOT needs. And these are going to be what replaces the storm tab sheets. So we'll have a custom flex table that looks as close to a storm tab as we possibly can get. And we've got some examples to show you of that already. And I'm going to go ahead and just get into a design file real quick that has that same thing laid out. So as you can see here, in the OpenRoads design software, I'm in a DRPR file, RD, and I do want to show you that If I hit my F9 key, I have several things referenced in this 2D view. I have essentially this DRMP, it's drainage map, but essentially this is where I laid out my drainage boundaries, and they're basically in here. I've also got a proposed pond that's been 3D. Whoops. My alignment file, which is the center line of my project for reference. I have my 2D representation of the alignment, I'm sorry, of the project. I have my terrain file referenced, and then I have the default 3D version of this file referenced. Obviously it's turned off right now. And then the actual corridor file that I created the model in, the 3D model from the 2D plans, is also referenced. So all these things are referenced in here, and I'm going to utilize those as I'm designing my drainage. So if I hit F5, then this is, and then I've got some drainage boundaries out here. That's what this is. There's a drainage boundary of this offsite. And then I've got some paved surface drainage areas, as well as some median drainage boundaries that are out here. So there is a little bit of prep work that needs to be done. Obviously, you need to have your corridor modeled. I also have a top mesh surface that I've turned off in this view. So let me go to my left and show you that in this corridor, this complete corridor file, there actually is a top mesh that's been turned off. And when I turn it back on, you can see that it shows up as white here. What I use this for is when I'm placing, or when you place your drainage nodes and you want it to use the elevation of the proposed surface, it's really easy to go to your corridor and ask for a top mesh of the backbone, and then use that to set your elevations. Now, if you've got the top mesh across your whole corridor, you're welcome to. My corridor happens to be broken. I chose to model this project. So the other thing is, I mentioned that in the plan, I actually have a referenced drainage map that has my drainage boundaries. It's recommended that you lay those out in a cell when you go to define your catchments. You can copy in those drainage areas, and then it's going to actually change them into a feature. And that's just so if anything happens, you'll still have your drainage delineation boundaries, because it actually rewrites them into a feature once they're in the file. So you can lay them out with MicroStation or any other tool for laying them out. But once you make them a catchment feature, it's going to change the status of them. So we recommend making a backup to that. Okay, so I'll show you the layout real quick. The first thing I want to show you is that your workflow tab, Subsurface Utilities, and as soon as you click on this, it's going to change it to the SUDA tools. All right, so the home tab looks pretty similar to what we see on some of the other workflows. It's not until you get into layout, analysis, components, utilities, tools, and reports that these are all custom to the SUDA workflow. So for example, if you wanted to place a new node, I'll just zoom into this intersection, and let's say I want to place another inlet down here. I could go to the place node tool, and it will bring up the log box, and then within the FDOT Connect, we've delivered all of the things that you would need. So in the storm water nodes, I would put in a drainage structure. This would be a curb inlet. Let's say it's a type 10. And then it's going to ask for an element for the elevation. This is where I would want to pick this surface. Pick your actual corridor meshes. Sometimes I've noticed that it tries to set it at the bottom of this. So you see this pavement block here. Instead of picking the top elevation, it sometimes shows it at the bottom. So that's why I would recommend using the top mesh, because then it's only a flat surface. And then if you want to set a vertical offset, you can see it's already hanging around with me right here. So I'll just click over here. And then if you want to set a rotation angle on it, you can. The nice thing about this is once it's been placed in here, if it's not in the right location, it's really easy to move them. So you just click on it in the 2D view, and you get these manipulators. So if I want to change this orientation a little better and then click on it, you'll see there's a grip for the center. And then if I move it, I can actually move it back here to this curb location. Whoops, disappeared on me. Let me move it back. It must have snapped to some other element. So you gotta be careful. It does like to snap on things. I'll just set it right here. And now it's pretty close. I would obviously want to get in there and start manipulating it to get it a little closer. But like I said, the nice thing is that the 3D comes free, and there it's placed out there. So that's how easy it is to lay out your nodes. And of course, these are intelligent. When I placed it, I could have gave it a name, but if I click on it, you'll see if I go to my element properties, which I can go to the home screen and look for this little properties dialog. It will bring it up and it tells me what the name of that is. It also has what says these are the actual element properties, but there's also utility properties down here. So if I click on that, it's going to bring up all of the database properties that I just placed with that structure. Now, obviously, I didn't key any of these in. Most of it came from the design file. It was intelligent. This is what's being defined in what we call a catalog file. So over in the components, there is a catalog, an inlet catalog in this case. And so these have been predefined for the FDOT, these curb inlets. For example, I did a type 10. This is where it found the default information for all of those. This has already been set up. There's design info, lots of library info, and so on and so forth. Okay. Same thing with when you go to layout, if you go and lay out a link or a conduit in this case, it's going to ask you for a start node. Let me get out of the selection set. Place a conduit. So I'm going to have to go here, pick a acceptable feature to put in between two storm inlets, and that would be, in this case, a drainage pipe. I'll do a circular pipe, and I can start with a default of, in this case, I'm going to do a 15-inch pipe, and it asks me for the start node. Now, you notice these this different line symbol, I don't want to call it, I guess it's a dot dash line or a double dot dash line. That is the connection plane, which is really mimicking where the bottom of the box is. So where on the box do you want to connect to? So I want to connect to one of these walls. So if I wanted to connect this pipe from here to my nearest other structure, you notice that there's a bottom structure on this particular structure here. So I could click there, or actually I would want to put it on this one. So I would just click there. And for any of you that have used SUDA in the past, this shouldn't be anything new to you. And it's going to go to that other structure. It was placed at the bottom, and then it tried to match bottoms here. So I don't know what the slope of this pipe is, but if I wanted to know, I could easily open up this pipe, go to a profile view, select the view, and now I can click on this, and it will have the actual slope value. And you can't see it on your screen probably because I have this display properties. Let me go over to my settings. Give me a second. File, design file settings, civil formatting. It's in here. No, it's not. It's preferences. My bad. So let me go to the user preferences right here. I know a few of you are screaming on the back there, trying to help me. I'll get there. I'm a little rusty, but I can still do this. Go here, let me change this a little bit. And for those of you that didn't know where that was set, now you do. And if I go back, now you can see that I've changed the highlight of that. So there's my percent slope on that. If I click on this link, so this pipe is pipe 8. The other thing the nice thing about this is that everything you place is over here in the Explorer tool. So all my nodes, so I just placed that structure 8 is right here and it'll tell me everything about it. I've also got links out here. So this last link is pipe 8. So if I click on that, I'll get all the properties associated with that. If I can open up the database, you see that I've got an 15-inch pipe that's been placed out there. There's the diameter right there. Okay, so let's see. As far as your catchment areas, so that's placing nodes, conduits. This is the extract graphics. So if you had I'll just draw a line out here real quick. It represents anything. I'll just go to my drawing tools here. I'm going to set my level to a scratch level. Just actually, let me use miscellaneous. All right, I'll just use this green color, and then I'm going to draw a line. And this is going to be pick a utility. I'll just decide that I want to go to the subsurface utilities layout, do extract from graphics, and then give it a feature over here. And I can pick let's say it's going to be a gas line existing, level B locate. And then as far as the size, I want to make this a 4-inch gas line. And the method is selection. So I can select on this element. And notice that right now it doesn't have an elevation, okay? So when I select on the element, it's going to ask me reset for that. So I'm going to select it first. I noticed that seems to be a little finicky. And then do extract from graphics. Now here is I can either use 3D. In this case, it doesn't have a profile. So I could give it a profile, or if it was already a 3D element, then it would extract it that way. So if I come to the profile here and open it up in this view, the nice thing about profiles is if you want this to be below ground, you can set a negative, like minus 2.5 feet. And that essentially just place the profile of this pipe 2 feet below the existing ground. And as soon as I make this active, it's going to draw a 3D line out there for me. Now, right now, it's just a 3D line on the miscellaneous 5 level. So this is where you would want to make it actually a utility. So again, let me select it first. And now here, the actual elevation of the object. It says select the surface or reset for the active terrain model. And I should have this enabled here. So I'm just going to go ahead and set this to minus 2.5. I just did it yesterday, of course, but no trench. And now it is a 3D gas line 4-inch. So that's how easy it is. You notice that in the profile view, now I have a pipe out there. Now, once you've placed these in here, you can't make manipulates to them because it's now ruled to this database. So you just, whenever you get your existing utilities, that's how you could set that up. So that is the extract from graphics. We're also looking at doing the import from a SS4 SUDA And then we're also looking at possibly importing from an ASAD database. But as far as the getting started stuff goes, we haven't really got that far on that yet. Okay, so that's placing everything. Under the analysis, you can set up different scenarios. So in this case, I have a scenario set up for I believe it's a 3-year storm event, and that's set up over in one of these default design constraints, I believe. I'm not going to get into the details, but you can either have the system totally redesign it for you or have it analyze what you've already laid out. And so I've already computed this once with the analysis that I have. And then if you want to review anything about it, you can go to these profile runs, which under the layout, there is actually create hydraulic runs either from the outfall structure or to the outfall structure or between two links or the entire project. And what it'll do is it'll create all of these different runs. So in this case, S7 to S8 is basically from here to the outfall structure. And I did skip over placing catchments. So when you place catchments, that is basically your drainage boundaries. You can do it from 3 different ways. Either you can pick a shape, pick points, or fill. I haven't had a whole lot of success with the flood fill, but I do, if you've already got your shapes, which is probably what you would do, you would pick that and then select the feature for catchments. And notice that we have all of the different land use types, or a lot of the land use types. So in this case, I would have picked pavement, and then you can pick on, well, let me change this to a grass and just pick this, and you'll see what happens when I pick this offsite drainage and reset. And now this should be a catchment area that can be defined and attached to a structure. Back to profile runs. So once you've computed or done your analysis, or anytime you want to open up a profile, you can open up a profile the way I did. Or in this case, I've got this S7 to S8 structures. Notice how it has 4 pipes in there. Depends on, now there's 3 different types of profiles. You can open up a regular CADD profile, an analysis profile, or an engineering profile. I'll open up all of these. In SUDA, you can also create profiles between nodes or along your network. The easiest way to create the profile runs for your entire project is to just run to this, right-click on the profile runs and choose hydraulic runs to outfall, and it will ask you for the outfall structure. So that'll be the most downstream in your network. And then it's also going to ask you for a feature to draw to. So it defaults to a alignment baseline. I think it's the first feature in our feature library. I usually switch it to a construction element. In this case, a construction line red dash. And then left click one more time to accept it. And it will go off and it will create all of the profile runs in the project for you. And then if you open up the list here, you'll see that you have each of these profile runs. Now, if you right click on, and for this example, I'm going to right click on the first run, which is going to be from the structure here, the last structure that I created, to this outfall. So it's pretty much the longest reach. And I have 3 different types of profiles that I can open up. Now, it likely isn't going to, yep, there it goes. Since the network has been designed, it will give me the different profiles. You can see this is a engineering type profile that has some labels. What I did notice is that these inverts are really for the bottom of the pipe, not necessarily the top of the ground elevation like it shows here, so they're labeled a little differently. That's one type of profile. The next profile that you can create is this analysis profile, and this will show essentially the hydraulic grade line and the energy grade line going through the pipes. And it gives a representation of it. It's not a whole lot of control on this one. It can be saved. Notice I can toggle on certain things here. I can show a legend if I want over here, which shows the hydraulic grade line, but it's pretty much straightforward. Looks like there is some annotation labels and I'm sorry, a annotation profile labels. So table rather. So there's some out of the box diagrams and profiles that could be useful in a drainage report. The other profile is an actual CAD profile. So if I right click and choose open profile model, it's going to ask me to select a view. So if I choose view 4, now I can see the actual profile as it goes through CAD. Now the other thing about this profile is if you want to see the rest of what's along the trunk line in the model, so in other words, if I wanted to see where the roadway plots, not just the existing ground, there is this tool here which is create 3D cut. And essentially what this is going to do, it's going to cut the rest of the model meshes into this view rather than just have the existing ground and the pipes. It's going to include everything else. So the best way is to just choose the placement method by corners and then locate the start and basically just draw the clipping plane that you want, and it will regenerate the profile. And now you can see the curb exaggerated right here at the beginning, and of course you can see the curb here toward the end. This one isn't really as good. Like for example, if you wanted to see, let me see this the roadway across one of these profiles. Let's just go to this one right here. Let me see what structure this is. Structure 6 to structure, well actually let me go across this one right here. So this is structure 1. This is structure, I'm sorry, 0 and structure 8. So from 1 to 8, which I don't see, but we can do this structure 1 to structure 0. If I choose open profile model, this is going to be the one going across the road. And then if I wanted to see the roadway, I could choose this and pick a start point and an end point, and it will draw in the roadway. And if I want to change this, the nice thing is you can click on this boundary and you can actually change it. So if I want to extend it out, if I grab this little plunger, when I grab this plunger and then let me just run that. It should have updated this view. That's what I was expecting. If I wanted to see the run from here all the way to there, I could easily go to profile runs and choose, it's not there. I can actually do it, utility run from nodes. It's going to ask me for the start node, which will be this one, and the stop node, which will be this one, and then click to accept. And I should get a new profile run there, which is called profile run. And if I click on this again, you'll see there's probably a name for it right here. And notice that it used that same feature baseline, so I should have been a little bit more careful. But now if I right click on this run and choose open profile model, I'll get it all the way across to the outfall structure. And then I can do that same thing, and I can choose to show me the roadway across there. And now I get to see my drainage structure superimposed with my pond and my super elevated roadway going out to the other side of that berm.
And that is the profile tools within SUDA.
For the sake of time here, let me just open up some of the flex tables on the SUDA. And again, if you go to the components, the analysis, there's flex tables here. And these are the, if you will, the reports here. So it's going to bring up everything that's been placed out there in this file for my network. This is, like I said, as close as we've gotten. Notice a lot of the values are not applicable in this case. I need to rerun the design analysis, having added that pipe apparently. But this is where you would get a lot of that data. There's also spread reports, inlet reports that'll have specific information. We're working with one of our drainage consultants to help us develop these based on what is typically used for drainage reports. So a lot of that, the drainage analysis that goes in your reports will be available through SUDA as well. The planned production side of it, currently anything that's been placed in this file can be easily labeled, if you will, using just standard drawing production tools within MicroStation. So for example, if I wanted to label this node here, I could easily go into the element properties using just the place label tool. I could select on this structure and it will bring up a list of properties, even SUDA properties that are out there. So if I needed to label this as its structure number or what type of structure it is, what size it is, anything that I would normally want to label on a set of plans is available here. So if I want to use this node information, it'll pick that node, and then I just click on it, and not that one. I actually got to click on the structure. Says line, but it should be actually labeling it similar to this. And if you want to build a note, like in this case, I built these notes, construct so many feet of pipe. You can do the same thing. You just start keying something in, pick the element, pick a property. Like in this case, I picked the length and I picked the size, and it built the note once. Once I have it built once, I can go click on every single one of them and place them out there. What I was trying to do was, you'll see here that I've got this drawing boundary, and if you've been paying attention to a lot of our plant production tools, you'll note that our sheet production is done off of drawing boundaries using the place name boundary tool. So I actually have one out here. If I go to my models, you'll see that I have a Plan 3 drawing model and a Plan 3 sheet. So if I double click on this, this is that clipped area. And what I was testing was to see when I label, if I can label in the drawing model the same way, and that this text favorite tool doesn't work off SUDA properties, so it's supposed to be something that they're fixing for the next release, but that's what we hear about everything. So you will be able to label in drawing views on the SUDA features that are out there. That's my point. And of course, this would be a typical plan sheet that I'm sure is placed in there as well. Sorry, I'm going to skip the profiles just for the sake of time. And I've kind of talked about all of the others. I want to move into the gINT tools with a little bit of time that we have left. And obviously, if you have more questions, please feel free to key them in, and we'll address them through the Q&A. Okay, so when it comes to the geotechnical data, Bentley has incorporated a product called gINT. A lot of people call it, it's gINT, Civil Tools. It's a database that geotechnical engineers have been using across the nation for some time to collect all their exploration of core holes and boring logs and auger borings and whatnot on different sites. So there actually is tapped into a large database, if you will. And so the MicroStation or OpenRoads Designer Connect Edition now has a version of gINT to be able to read the database and display the information from the database into a MicroStation file. It does replace the legacy Geopack borehole navigator, or in Civil 3D, we basically rewrote the borehole navigator to look like what was in Geopack. So gINT is a totally new tool set. It's pretty straightforward and easy to learn. Like I said, first thing I recommend, first thing that we all do is go to the Bentley Learn and go through the, you'll notice that some of these are 2 minutes, 45 seconds, 3 minutes, for all of the little tool sets that you would need to know how to do. I'm going to show you a little bit of them in the time that I have left, but I would recommend going out to the Learn server, keying search for gINT, or going to your Connect Advisor, if you have that open in MicroStation Connect, key in the word gINT, and you will find videos, you know, everything you would need to start learning it. As far as the DOT Connect version, of course, it's all incorporated in the FDOT Connect because it's part of OpenRoads Designer. But essentially, we're going to open up a gINT project file or a gINT Excel spreadsheet, and then display the boreholes in a plan view. Again, you can display them in a model. It is a two-step process within gINT. You have to display them in plan first, and then you can display them in 3D, but you don't have to draw them, it does it. And then from there, you can label them, you can show them on plans, in profiles, on sections if you need to. And just to show you, so there's a typical set of roadway plans, and this is typically where you see the geotech information get presented. Sometimes it's on plans, sometimes it's not. In this case, it actually wasn't in this plan set, but it was, there was specific pond detail sheets and reports of the borings. There was a roadway soil survey. Even though the roadways weren't plotted on the plan, they were plotted on cross sections as per the FDM. This is a typical soil survey sheet, has everything grouped by soil type for the different soils that were found on that project. Of course, this is what people are used to seeing. And then, of course, they have this index of soil types labeled this way, but then there's a description next to it as it's presented on this report sheet in this case. And so I'll show you where these tools are going to be in the gINT. So just like within SUDA, there's a geotechnical task menu that you can open up, and then it has various tabs for the tools that you would use. Once you've opened up a database, you can then choose to present them in the plan, which is what's happening here. Then you can annotate them, which will annotate by any of the properties of the actual spreadsheet. So in this case, I chose the name of each of these tables, which was borehole number. They're also presented in 3D. And so you'll see in the project properties, there was 10 boreholes here, and they're each plotted. They're not exactly on these center lines. I don't know if I did a closer. If you get a close-up view, you see that the lithologies are plotted on levels according to the classification type. In this case, we have created gINT levels for the SCS method soil types. I'm probably going to also add the AASHTO designations as well. So depending upon how they're classified for either roadway or structure borings, when they plot to the file, they will pass QC, because right now gINT just writes into the levels based on the lithology name, but that's more detail. As far as getting these boring holes on cross sections, with anything in the OpenRoads Designer Connect Edition, the only way to display something on a cross section is by creating a slice through it. So it actually has to be in the 3D model. And then once it is, it will display on a cross section or a profile or anything of that matter. If you have a borehole that's not within a specified cross-section interval, it will not plot on a cross-section. It will not project to a cross-section. The only way to get boreholes on cross-sections is if the boring is located at that station that you cut the cross-section. So that's just something to know going forward. And with that, let me get over into the software and close out of this file. I'm going to switch over to a different project or work set. And I want to open up this project design file here. And just like anything else, you would create your own separate design file to display the boring 2D information, 3D information. And then of course you would go to a cross-section file, and anything that's referenced in to a model will present itself on a cross-section, including boring logs as well. So as this loads, I want to switch over to the FDOT menu real quick, and in the Create File tool, there are geotech files that you can have. Actually, it's in this section here, geotech, and you'll see for Roadway, there's various file types. So I just created this A bore for auger borings and plotted those into the file. Now I've got, let me get this view. Let me shrink this view up here a second. View, tile. Okay. So just like the other SUDA file, I have several things referenced in here, and then I've dimmed out all of the reference files. So all I'm really seeing in this file is where these plotted borings came from. And if you go to the geotech and go to of course, it has most of the standard MicroStation home tools. Now this is where you can connect to a gINT database. And essentially you have the option to go to the actual SQL version of the gINT database that is provided to you through geotech, or you can ask them to send you an Excel file. So I'm going to search out in this project folder under my geotech. And I want to show you what one of these project files looks like. So this is the SR61 sample Excel spreadsheet that's been imported. So I'm going to open this up and show you the format of it. So there's essentially right now, there's only 3 tabs. I have a project tab, and this has all the project specific information about this project. So that could be a project number, it could be a location of where it is, what the datum elevation is. It's just general project data. And then these are all of the points or boring locations that were located. So now this has columns, and there's a sample one that's delivered in our workspace. So it has the level you want to plot these boring targets to, what the depth is, some of the more specific information that's specific to that borehole, size, contractor. You'll also notice it has a northing and easting, but it doesn't have a station and offset. Right now, I've only been able to work with northing eastings. So if you get them in station offset, what I did was just convert those. I plotted the station offsets and went in and converted those, but I'm pretty sure that this gINT database will give you northing, easting, lat, long, whatever you ask for. And then once you have it in the file, you can always label it by station offset. And then for each of these borings or these holes, you're going to have the lithology that goes with it. So this borehole 1 has these 2 soil types in it. From 0 to 5 feet is this dark brown silty dense material, and they've used a USCS classification of SP for poorly graded sand. And this is where if this comes blank from your geotech, you can actually go in here and match up the level to the level that you want it to plot on. Or you could ask the geotech engineer to actually use the FDOT levels, and they'll be in the CAD manual as far as which levels to use. Like I said, right now we just have the USCS levels. I'll probably be adding the AASHTO levels as well if they want to classify by that classification type. And then once you have all those, then it's just a matter of connecting to it. So I'm not going to save this. When you come over to the database connectivity, I guess I'm still in this browse tool. So I've already connected to this one once, and then if you go to the borings, this is where you can set up the properties of how things get displayed. And so this doesn't actually have any tools to display to the design file. What you actually do is you go to this query tool, and you can query everything from the selected database in the file. Well, it says to connect, I didn't turn it on. Okay. And then you do a query all. Okay, it's open. I'm trying to bring up this one query all. All right, well, believe me, this will query the database, brings up a dialog of everything that's been in there, and then you plot to either the 2D or the 3D. Now, once you've got these in 3D, like I said, if you want to present it on a profile, if you can create a line between them, or I've got another file here of some of these results. So in this case, this borehole happened to be right at that station 702. And these are now plotted out here on the specific levels, okay? And with levels, you can create what's called element templates. So in the element templates manager here, we have a gINT element templates, and for each of these, they're now mapped to a pattern cell. This is similar to the way we used to plot things on the old borehole navigator. When it was presented on a cross section, it used a specific pattern cell. So what we've done is we've set up an element template for each of these levels, and then if you slice through it, it gets presented in that with a patterned area as through that hole. So let me show you the results of that. If you go to a model here and go to this drawing model 702 and zoom into here, you'll see that this borehole is now plotted on this cross section, and it's been hatched according to that material pattern. And it's also got a shaded color that goes with it. Now this is also similar to what I presented over there in the SUDA tools, but if you want to go to the annotation and place labels, you can pull information straight off of the file. So if I wanted to click on this, it does have all the boring data here too. So if I wanted to label this borehole number and then click on this, it should use a FF small. All right, F small is too big, but it will label it that way as too. Profile, one of these, F.sheet, I thought there was one for cross sections. Cross-section annotation, PGL elevation, let's try that. There you go. And if there was any other properties like northing, easting, or elevation that you wanted to plot, you could plot that information to it as well. So that's how you would do most of that. It isn't an automatic thing that comes in with it every time. There's going to be some manual annotation work right now. We may be able to create some cross-section annotation groups to automate a lot of this in the future as we get farther along. But right now the tools are there. The tools are there in MicroStation to what I call semi-manually automate things. But hopefully this gives you a getting started lesson on how we're going to approach the geotechnical data and SUDA data within the new FDOT Connect environment. So I guess that gives us about 4 or 5 minutes for me to scan the questions and see if there's anything that I can answer right off the top of the bat. Some of these standard questions we'll have to look into. There's one about barrier wall inlets. We'll have to look into that. I didn't know there was anything changing on it. It may be something we've already addressed. Like I said, we have a consultant that's working with us to help us certify all of the tools within SUDA. These are good questions. Another one about the table 6.4.6 recommended minimum angles. Does SUDA or ORD have the intelligence to conform to these design criteria? So right now, no. I don't think there's a way to do that. Obviously, it's going to let you place structures however you can physically place them, but it's still going to be up to the drainage engineer to certify it or to sign and seal it according to the FDOT criteria. There may be some tool in there that will resize these boxes in the future that we might have some more of those capabilities, but I don't believe it's there in the current version. So there's a question about, looks like Angela did answer that one, about checking vertical clearances. That'll be in the Q&A. Will drainage still need to be shown on the roadway profiles? The only way, there is a way to show drainage on roadway profiles. Whether or not that's going to be a requirement is still not officially been determined. I think the answer is no, they won't be required. If we're going to be delivering a 3D model of the drainage, then they're not necessary to be on a roadway profile. Do you have the capability? Yes. There is a tool within a vertical alignment that allows you to, I can't really show it, see in this file, but there is a tool that allows you to view all of the 3D elements within a profile or across the profile on a profile. So if the drainage structure is along the line where the profile is being drawn, then yes, you will be able to view that. But it's not as easy with OpenRoads to just project things to a centerline profile. Not necessarily easy. It's just it's not true. It's not a true representation of the profile or the cross sections in that matter. So that's why the software doesn't provide those capabilities. Is GINT built into OpenRoads? Yes. If once you get once you've got a license of OpenRoads Designer Connect, GINT is part of it. And then it looks like most of these other questions have been answered. How to show a borehole in the next even station on a cross section. Right, again, the boreholes do not project to a cross section the way you could have them project with the old Geopack tools. It has to be true. So you could either create cross sections at those odd intervals and show the boring logs, or just if you needed to, you could just rely on the soil survey sheets and have all of the lithology for each of the boreholes already placed there. We're going to rely in next gen plans more heavily on the geotech report and all of the presentations of the geotechnical information there, and then refer and label from the 2D targets and the 3D holes with the lithologies in order to provide that information to the contractor is the way it looks like we're headed. All right. Well, looks like we're up against the hour. That is the end of this getting started session. Hopefully you've learned a little bit about the SUDA and geotechnical tools, and please stay tuned for the next scheduled webinar, and thank you for attending. This is the end of today's webinar. Thank you.
Thanks, Vern. And of course, once again, this will be posted as a recording to our website under the posted webinar section of our website, along with the question and answers. Thanks for attending.